Hey y'all! So in today's video, we will continue our Python for Data Science series and discuss Python lists. More specifically, I will go over an introduction, discuss what a list is, creating a list, discussing how to access, modify, append, insert, and remove elements, as well as negative indexing, slicing lists, looping through lists, list comprehensions, other useful list methods, best practices for using lists, and some practical examples. As always, this video is timestamped, so if you'd like to skip to a specific section, feel free to do so by clicking on the timestamp down in the description. So let's get into it. Let's tech talk with Tyler. So lists are a fundamental data structure that allows us to store and manage collections of items. So let's break down the components of what a list is and how to use it. The formal definition of a list is an ordered, mutable collection of items in Python. This means that the items in the list are stored in a specific sequence, and we could change the items after the list is created. So ordered, what does that mean? Lists are ordered collections, which means that the items have a specific sequence. Each item in the list has an index that starts from 0. So for example, in the list 1, 2, 3, 4, 5, the first item is 1 and the index is 0. Lists are mutable, meaning that we could change the items in the list after it's created. We can add, remove, or modify items for the list. So for example, we could change the first item in the list to 10. Lists are very powerful and flexible. They allow us to store multiple items in a single variable, and we could perform various operations on them, such as adding new items, removing items, and modifying existing items. Lists can also contain items of different types, such as integers, strings, and even other lists. In Python, lists are versatile and can store items of different data types, such as integers, strings, and even other lists, just like we said. So let's see how we can create such lists. So for a list of integers, a list can contain only integer elements. The code snippet pictured shows an example of a list with integers. A list can also contain only string elements. The code snippet pictured shows an example of that. One of the most powerful features of Python lists is that they can contain elements of different types. This means a single list can store integers, strings, floats, booleans, and more. The code snippet pictured shows an example of a mixed type list. So this flexibility allows us to use lists to store and manage collections of various data types in a single list. This can be very useful in data science and general programming, where we often need to handle diverse sets of data. So indexing allows us to retrieve specific elements from a list based on their position. So let's break down how indexing works. To access an element in a list, we use square brackets with the index of the element inside. And the index specifies the position of the element in the list. So in the first code snippet, we see the 0th index of the numbers list being printed. So you may know this, you may not, but Python lists use zero-based indexing, meaning the first element is at index 0. The second element is at index 1, and so on. So for example, the list numbers equals 1, 2, 3, 4, 5. The element at index 0 is 1. We can also use negative indices to access elements from the end of the list. The last element is at index -1, the second last element is at index -2, and so on. So for example, in the list fruits equals apples, banana, cherry, the element at index -1 is cherry, exactly. So indexing is a powerful way to retrieve specific elements from a list. It allows us to quickly access and manipulate data stored in lists, which is very useful in data science and programming in general. So lists in Python are mutable, which means we could change their elements after they are created. So let's see how we can modify elements in a list. What methods do we need to know? So to modify an element in a list, we use indexing to specify the position of the element we want to change, and then we assign a new value to that position. This will update the list with the new value. So let's consider a list named numbers with the elements 1, 2, 3, 4, 5. We want to change the value of the element at index 2, which is the third element, to 10. After modifying the list, we can print the list to verify that the changes have been applied. And there we have it. Modifying elements in a list is a fundamental operation that allows us to update and manage data effectively. This is especially useful in data science, where we often need to manipulate data stored in lists. Another important method is the append method. It's a simple and effective way to expand a list by adding new elements to the end. So let's break down how to use it. So this method modifies the list in place, meaning the original list is just updated. Let's consider a list named fruits with the elements apple, banana, and cherry. We want to add the element orange to the end of the list. We do this by simply using the append method. And then after adding the new element, we can print the list to verify that the new element has been added to the end. So using the append method is a straightforward way to expand your list by adding new elements to the end. This is very useful when you need to dynamically grow your list by adding more items. All right, the insert method. So this allows us to insert or add new elements at any position in the list. Let's break down how to use this method. So first, you'll need to specify the index where we want to insert the element and the element itself. So let's consider a list. We'll use the fruit example with the elements apple, banana, cherry, and orange. We want to insert the element blueberry at index 1, not at the end, which is the second position in this list. So we'll do this by using the insert method. After inserting the new element, we can print the list to verify that the new element has been added at the specified position. The insert method is a powerful tool that allows us to add elements to any position in the list, giving us more control over the structure of our data. So we spoke about adding. What about removing elements from a list? We can do that by using the remove and pop methods. These two methods provide different ways to delete elements from a list. So let's break down how to use them. The remove method allows us to delete the first occurrence of a specific element from the list. We need to specify the element we want to remove. So let's say we want to remove banana. We'll do fruits.remove banana. Meanwhile, on the other hand, we have the pop method. This still removes an element and returns the element at a specified position. If no index is specified, it removes and returns the last element in the list. So with the list named fruits, with the elements apple, blueberry, banana, cherry, orange, we want to remove the element banana from the list. We will use the remove method. We also want to remove and return the last element from the list using the pop method. And after removing these elements, we can print the list just to verify that the elements have been removed. And there we have it. The remove and pop methods are both essential for managing and manipulating lists. They allow us to delete specific elements or retrieve and remove elements efficiently. Slicing. That allows us to extract specific portions of a list by specifying a range of indices. So let's break down how this works. To slice a list, we use the slicing syntax list name, bracket, start, stop. Close bracket, where start is the index where the slicing begins, inclusive, and stop is the index where the slice ends, exclusive. The start index specifies the position to start the slice, and the stop index specifies the position to end the slice. So for example, in the list numbers, the slice numbers 1:4 will return 2, 10, and 4. If we omit the start index, the slice starts from the beginning of the list. If we omit the stop index, the slice goes up to the end of the list. For example, fruits:2 returns the first two elements, and fruits1: returns all elements from the second to the end of the list. Slicing is a powerful tool that allows us to extract specific portions of a list, making it easier to work with and manipulate data stored in lists. Looping through a list allows us to access and manipulate each element in the list one by one. Let's break down how to use a for loop with lists. A for loop allows us to iterate over each element in a list. The syntax is for element in list name, where element is a variable that takes on the value of each item in the list during each iteration. So for example, we have for fruit in fruits, print fruit. So with the list named fruits, with the elements that we discussed, apple, banana, cherry, we want to loop through the list and print each element. How do we do this? We'll say for fruit in fruits, which is the list name, print fruit. Looping through a list is a common, simple, and powerful technique in Python. It allows us to access and perform operations on each element in the list, making it easier to work with collections of data easier. List comprehensions allows us to create new lists by applying an expression to each item in an iterable, all in a single line of code. So let's break down how to use list comprehensions. The syntax is open bracket, expression for item in the iterable, close bracket, where expression is the operation to apply to each item. Item is a variable that takes on the value of each element in the iterable, and iterable is the collection of items, such as a list or a range. Stick with me here. So for the example with what we have on the screen, the squares equals, let's create a list of squares of numbers from 0 to 5 using a list comprehension. This will generate a new list where each element is the square of its index in the range. So for example, we have the square equals open bracket x asterisk asterisk 2 for x in range 6. After creating the list, we can print it to verify the elements. So let me explain. The expression x asterisk asterisk 2 calculates the square of each number in the range from 0 to 5. The 4x in range 6 part iterates over each number in the range, applying the expression to generate the list. List comprehensions are a powerful and concise way to create lists in Python. They can simplify your code and make it more readable by reducing the need for multiple lines of code to create and populate lists. The least amount of lines, the better. So other useful methods include sort, reverse, index, and count. Let's explore how to use each one of these methods with examples. The sort method sorts the elements of the list in ascending order. This operation modifies the original list. Pretty self-explanatory. The reverse method reverses the order of the elements in the list. This operation also modifies the original list. The index method returns the index of the first occurrence of the specified element in the list. If the element is not found, it raises a value error. Another one is count method. And this method returns the number of times the specified element appears in the list. These list methods are very useful for manipulating and analyzing lists. They allow us to sort, reverse, find the position of elements, and count occurrences efficiently. Pretty helpful in our exploratory data analysis portion of data analytics. And that's all that I have. I hope that by now you have a better understanding of what Python lists are and what they could do than you did a couple of minutes ago. If you have any questions, comments, or even other Python topic suggestions, please leave a comment down below. Also, if you aren't already, subscribe to my channel and click the bell icon to be notified when I post another Python series video. Thanks for interacting with Tech Talk with Tyler. I'll see you later.